Have you ever gotten off a roller coaster and thought, how am I alive right now? Because it feels like chaos. But modern coasters are the opposite. They're controlled, calculated. Basically, a flying math problem made of steel. In the next few minutes, I'll show you the hidden engineering behind modern roller coasters, how they control speed without engines, why loops aren't actually circles, and the invisible safety system that keeps everything from turning into a disaster. Roller coasters look like pure madness. Big drops, twists, inversions. But what you're riding is closer to a precision machine than a thrill ride. Every scream is basically you reacting to physics, working perfectly. And once you see what's happening, it's hard to unsee it. Let's start with a big misconception. Most roller coasters don't have motors pulling them the whole time. They get one big boost, then gravity does the rest. That first lift hill, that's the coaster charging up. You're being pulled up with a chain or cable, and you hear that classic sound. That's not just for dramatic effect. That's the anti-rollback system. It's a mechanical lock that stops the train from sliding backward if power fails. Now, launch coasters are different. They skip the hill. And they throw you forward using systems like linear motors or hydraulics. Same idea, different method. Either way, the coaster is getting energy up front, like winding up a toy car, except the toy car weighs tons, and it's full of screaming humans. And after that first boost, the ride is basically spending an energy budget. Every hill, every turn, every loop costs energy. Designers are literally budgeting your fear. Okay, real question. Why doesn't the train fly off the track? Because when you're upside down, it sure feels like you're hanging by luck. But you're staying put because of forces, and because the train is locked onto the track in a way most people don't realize. Coaster wheels aren't just sitting on top of a rail. They use a three-wheel system. First, wheels on top. These carry the weight. Second, wheels on the sides. These keep the train from sliding sideways in turns. And third, wheels underneath. These are called upstop wheels. They clamp the train to the track during airtime and inversions. So when you feel weightless, the train isn't about to leave the rails. It's literally hugging the track from three directions. That floating feeling you love, that's negative G-force. It's not the coaster dropping you. It's the coaster reducing how hard the seat pushes on you for a moment. It's controlled weightlessness. And yes, engineers designed that on purpose, because humans apparently enjoy being terrified safely. Here's something that blows people's minds. Modern coaster loops are not circles. Old coasters used circular loops sometimes, and they were brutal. At the bottom of a loop, you're moving fast, and a circle makes the forces spike hard. So modern coasters use a different shape. It looks more like a teardrop, tighter at the top, where you're slower, wider at the bottom, where you're faster. That shape keeps G-forces in a safer, more comfortable range. So you still feel intense, but you don't feel like your head is trying to leave your body. And then there's banking. When a coaster turns, the track tilts, like a motorcycle leaning. That way, the force pushes into your seat, not sideways into your neck. If you've ever ridden a coaster that feels smooth, that's not luck. That's good geometry. And if you've ridden one that feels like it's trying to rearrange your spine, that's also geometry. Just not the best kind. Now let's talk about the part nobody sees. The control system. Modern coasters are designed around something called block sections. The track is divided into zones, and only one train is allowed in a zone at a time. So even if a coaster runs multiple trains, they're never allowed to get close. If a train hasn't cleared the next section, the system simply won't dispatch another train into it. And braking isn't just one big stop at the end. There are brake runs placed strategically throughout the ride. Some coasters use friction brakes. They clamp down like a car brake. But many modern coasters use magnetic brakes. And these are amazing. They slow the train without even touching it. They use something called eddy currents. Basically, the train passes through a magnetic field, and it creates resistance, like moving through invisible syrup. And here's the best part. Magnetic braking systems can be designed to be fail-safe. Meaning, if power fails, they don't turn off. They default to safe behavior. So in a weird way, when something goes wrong, the coaster often becomes. That's what good engineering looks like. It doesn't just work when everything is perfect. It works when things aren't. Another surprise, coasters aren't built to be perfectly rigid. They're designed to flex a little. Steel expands and contracts with temperature. The train creates vibration and dynamic loads. Wind pushes on tall sections. So engineers design the structure like a skeleton. Strong, supported, but allowed to move slightly so it doesn't crack under stress. Supports aren't placed where it looks stable. They're placed based on how forces flow through the track. A big drop creates one kind of load. A fast turn creates another. A loop creates another. Every element has a different force signature, and the coaster is built to survive the worst-case moment, again and again, for years. Quick myth check. Myth: the operator is basically driving the ride. Truth: the ride is driving itself with sensors and automated safety logic. Myth: faster always means more dangerous. Truth: shape matters more than speed. A slower coaster can feel more intense if transitions are sharper. Myth: the big drop is the most complicated part. Truth: transitions are. That's where forces change quickly, and where comfort is won or lost. So here's what's really happening when you ride. 1. The coaster runs on an energy budget. 2. The train is clamped to the track with multiple wheel systems. 3. Loops are shaped to control G-forces. 4. Block systems and brakes prevent trains from ever conflicting. 5. The structure is designed to flex safely, not stay perfectly still. So, yeah, when you scream on a roller coaster, you're reacting to one of the most controlled machines you'll ever sit inside. And next time you ride one, listen for this thought. This isn't chaos. This is engineering, pretending to be chaos. And if you've ever wondered why some coasters feel buttery smooth, while others feel rough and shaky, that comes down to track shaping, wheel materials, and something called jerk. And that topic gets weirdly intense.